Okay, so in Chapter 8, we're going to be particularly concerned with something called a square root of a number. Square roots are going to be important to us in Chapter 8. So what we need to learn today is how to take square roots when possible and how to simplify square roots when it's not possible to actually take them. So what a square root looks like is like this. And what a square root is asking us is what number times itself gives us that number underneath. So what can I multiply by itself that would give us 9? 3. So sometimes it's possible to actually take a square root. There is a nice clean number that gives us that value. Sometimes it is not possible to do it cleanly. There is nothing that I can multiply by itself that's going to give me 8. Okay? 2 times 2 is 4, 3 times 3 is 9, and now I've already passed by it. So it must be somewhere between there, but it's not a nice clean number. We could type it into our calculator and get a decimal approximation, but that decimal is going to be something that's called irrational. It's going to be messy. It's going to go on forever and ever and ever, and it's never going to start repeating itself or forming any pattern. So what we want to do is simplify the square root. When we use the word simplify, what we mean is get the number underneath the root to be as small as possible. But it has to keep the same value. Just like 2/4 and 1/2 are exactly the same, they just look different, we want to do that type of thing here. To do that, what we want to do is find a perfect square, a number we can take a square root of, that divides into the number in the problem. So you might want to create for yourself a list of perfect squares if you don't know them comfortably. So 4 is called a perfect square because 2 times 2 is 4. Okay. 9 is a perfect square because it's 3 times 3. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 gives 81. 10 gives 100. 11 is 121. 12 is 144, 13 is 169, and it's perfect that that hit the bottom of the board because that is as far as I know. Beyond that, I would just grab a calculator and try stuff out. What is 14 times 14? What is 15 times 15? And I just don't bother to commit any of those to memory. So what we're going to do is look to this list of numbers and say, what is the biggest number on this list that divides into the number in our problem? So what is the biggest number on this list that divides into 8? 4. So we're going to rewrite this as the square root of 4 times the square root of 2. Because 4 times 2 is 8, and it's all still under square root, so this is exactly the same thing. We're just rewriting it in a different way. Then, if a number is a number we can take a square root of, we want to actually do that. So the square root of 4 is 2, because 2 times 2 is 4. The square root of 2 is not a nice number. If we type it in the calculator, we'll get a long, ugly decimal. So then we just leave it and let it be. So if it has a perfect square, we take it. If it doesn't, we just let it be. And that is our answer. That is considered simplified. A lot of students don't think it looks simplified because there's more to it than there used to be. But the idea of simplified is we want the smallest possible number under the root. Let's try 75. 75 is not on the list, so we can't take a square root of 75. What is the biggest number on the list that goes into 75?
25.
25. So we're going to break this up to be square root of 25 times square root of 3, because 25 times 3 is 75. Then, if it's a perfect square, we want to take it. So the square root of 25 is 5, because 5 times 5 is 25. And there is no nice number that I can multiply by itself to get 3. So the square root of 3 is just going to stay square root of 3. Square root of 128. Now I said you want to find the biggest number on the list that goes in here. If you happen to not find the biggest number, if you choose a smaller number, it doesn't mean you're going to end up with a totally wrong answer. It just means you're going to have more work to do. So it is to your benefit to look for the biggest possible number that goes in there. But I will show you what to do and what happens if you don't happen to find it. But what is the biggest number that goes into 60 or into 120? 64, right? Oops, kind of gave it away. Okay, so 64 goes in twice. Square root of 64 is 8 because 8 times 8 is 64. And square root of 2 just tags along. Now, if you hadn't found the biggest possible square root, so if you didn't notice 64, but let's say that you thought 16, okay? 16 does go into 128, 16 times 8. This isn't going to give us a wrong answer, it's just going to give us an incomplete answer. So then we're going to have some more work to do. So 16 has a square root of 4, and there's square root of 8. But that answer is not complete yet because there is still something on the list that goes into 8. So we need to break this down more. So the 4 we're just going to leave out front. And what goes into 8? 4. So that 8 is going to become a 4 and a 2. That 4 from the front is just going to tag along. The square root of 4 becomes what? What's the square root of 4? 2. And then that square root of 2 we can't do anything about. And now if I multiply that 4 and 2, I get 8 square root of 2, and we get the same answer. It was just more work. Okay? So if you miss the biggest thing in the list, you're not wrong, you're just not done. Okay? So when you are going through a problem and you think you are done, always double check that whatever is left under that root is as small as it can be, that there's nothing left in the list that would still go in there. So if you think you get to an answer of 4 square root of 8, make sure you double check through the list and go, oh, actually, 8 can break down and be 4 times 2. Okay, so you're not wrong, you're just not done. Okay, it is fastest if you can find the biggest number that goes in there. But picking any number will work. It'll just be more work along the way. Okay? Your calculator will not do these problems for you, but you can use it to check your answers. Right? There's no way on the calculator to tell it to simplify a square root. That's just not a function that it has on it. I don't know why. It seems like it'd be a pretty helpful thing, actually. But it doesn't. But you could check your answer by typing in the original problem. So you could type in square root of 128. It's going to give you a long, messy decimal. Okay? That is not a right answer. Decimals are not correct answers to these questions. Okay? So you could type that in and see what that decimal is. Then you could type in what you think the answer is. So you could type in 8 times the square root of 2. And that should also give you a long, messy decimal. And if it's right, it'll be the exact same long, messy decimal. Because when we do this simplification, we're not changing the number. We're just changing the way that it looks. Just like 2/4 is exactly the same as 1/2. It just looks different. We're doing that thing here. It's the exact same value, it just looks different. Okay? So you can use your calculator to check by making sure you're getting the same decimal answer. But the calculator won't actually do it, and the decimal won't be considered the right answer. Okay? I'm going to do one more of this type. Okay, so this one has a number hanging out in front. If that happens, we're just going to let it hang out in front, and we're going to deal with the square root of 72. So what is a number on that list that goes into 72?
36.
36 is the biggest. 9 also goes in there. 4 also goes in there, and those would all be okay things to do, but not the quickest things to do. 36 is the quickest thing to do. 36 times 2. And that 3 is just going to stay a 3 right out in front of the problem. Then when we evaluate this, the 3 is just going to stay a 3 out in front of the problem. The square root of 36 becomes 6, and the square root of 2 is not nice, so it just stays. Then that 3 and that 6, we can multiply together and make 18. Square root of 2. Okay, so if there's any number outside of the problem, it's just going to stay outside the problem until you're all done, and then multiply it with anything else outside. If you have more than one thing underneath roots, you can multiply those together. So stuff that's outside can be multiplied together, stuff that's inside can be multiplied together if you end up with more than one root in your problem. Okay. Questions on this? All right, one more problem we need to look at is what to do with fractions. Okay, when we have a square root of a fraction, what we're going to do is first separate it so that it becomes a square root of the top all by itself and a square root of the bottom all by itself. Okay, so a square root of a whole fraction can be separated to be a square root of each individual piece of the fraction. Then we are going to want to take or simplify those roots when possible. So square root of 9, 3, because 3 times 3 is 9. Square root of 2 is not a nice number, and 2 is already so small that nothing that we had on that list can go into it, so it can't even be simplified. So it's just going to stay square root of 2. This answer is not considered appropriate, though. It is considered inappropriate to leave square roots on the bottom of fractions. Now, why it's considered inappropriate is kind of a historical thing. Before we had calculators readily available, if we wanted to do something like 3 divided by square root of 2, what we would have to do is find a table of square roots. So there would be these big old tables in the back of textbooks that would say square root of 1 is 1. Square root of 2 is long messy decimal. Square root of 3 is long messy decimal. Square root of 4 is 2. Square root of 5 is long messy decimal. So we'd have to look up on our list, what is the square root of 2? Then I would have to do 3 divided by that long messy decimal, long division by hand with the decimal. Not a nice thing to do. It is easier to divide a decimal by a whole number than a whole number by a decimal. So it became convention or practice or the normal way of doing things to not leave square roots on the bottom of problems, but to get them to the top instead. Now it's not really important anymore because now we have calculators. You can grab a calculator and you can do 3 divided by square root of 2 and it's no big deal. But it's still considered the convention or the practice or the normal way of doing things to not leave square roots in the bottom. Might seem kind of annoying, but so is grammar, right? There's just, in every subject, there's a way we do things that's considered the right way to do things. And this is just considered the right way to do square roots, is not to leave them on the bottom of fractions. Okay? So the way that we fix this problem is we are going to multiply by the square root that is on the bottom of the fraction. Okay. We're going to multiply whatever square root is on the bottom of the fraction. But if I just do that, that's not going to change the problem. And we don't really want to change the problem. We just want to change the way it looks. So I'm also going to multiply by that same square root on the top. Because what is square root of 2 over square root of 2?
1.
It's just 1, right? It's kind of a messy form of the number 1, but it's just 1. And multiplying by 1 doesn't change something. Multiplying by 1 keeps it whatever it is. Okay? So this will change the way that it looks, but it won't actually change what it is. So on the top, I now have 3 square root of 2. On the bottom, if I multiply square root of 2 times square root of 2, what do I get?
2.
First, I would get square root of 4, right, if I just multiply those together. But what is the square root of 4? 2. Anytime you multiply a square root by itself, you will just get whatever was underneath it. So square root of 2 times square root of 2 is 2. Okay, square root of 5 times square root of 5 is 5. Square root of 31 times square root of 31 is 31. Okay, you multiply a square root by itself, and it just gives you whatever was underneath that root. This is considered the final appropriate answer. Okay, square roots are okay and kind of expected on the top, but not okay on the bottom. So let's do another one. Okay, square root of 5/4. First thing we do, separate them. each get their own square root, then simplify or take the square roots when possible. So square root of 5, not a nice number, and nothing that we had on that list goes into 5, so it's just going to stay. Square root of 4, 2, and that problem's done because there's no square roots on the bottom. That's the problem. The bottom is the problem. Square roots on the top, totally fine. So this problem ended up done. Yes?
For the problem we just did, could you simplify square root of 5 to like square root of 4 and then like a quarter or whatever it is, and then just
It wouldn't be helpful. It's only helpful to separate it if something's a perfect square. So, and we don't want decimals in there. All right, so first thing we're going to do here, separate them out. Then simplify or take the square roots when possible. So square root of 7, not nice, and nothing on that list divided into 7. So the square root of 7 is just going to stay what it is for now. Square root of 8 is not nice. But what on that list goes into 8? 4. So we're going to turn this into 4 and 2. Then what is the square root of 4? 2. So that square root of 4 is going to become a 2. And the square root of 2 is just going to stay what it is. But this problem is not done. Because of that square root on the bottom, we're not allowed to leave that there. So we want to multiply by what's causing us a problem. The square root of 2 is causing us a problem. And we multiply by the same thing on the top and bottom. Now in our first example, it was also a square root of 2. It's not always a square root of 2 that you're going to do. It's whatever square root's on the bottom. Okay? So if you had a square root of 3 on the bottom of your problem, that's what you would multiply by. If you had a square root of 5 on the bottom of your problem, that's what you would multiply by. It just happened to be 2 in both of these. But you multiply by whatever square root is on the bottom of the fraction that's causing the problem. On the top, they are both under square roots, so I can multiply them together. Get a 14. On the bottom, I have this square root of 2 times square root of 2, which will be what? 2. But there was already a 2 there as well, so I multiply those together and get 4. That is done. You cannot simplify the 14 and the 4. A lot of students want to. They're like, oh, hey, look, both parts are even. Let's reduce it. Square root of 7 over 2. Okay? You cannot do that. You can reduce if they are both under square roots. You can reduce if they are both not under square roots. So if you had something like 14 square root of 2 over 2, you could reduce that stuff because it's not under square roots. But you cannot reduce when something is under and something is not. Okay, they have to be in the same location to be able to reduce them down, either both under or both not under roots. Okay? Questions? All right, so your homework for tonight is going to come from 8.1, which is page 288 in your book, and it is going to be numbers 1 through 15.